Hey, what's up? Jason here. So recently I've been doing a lot of playing with machine learning stuff. I put up a couple videos on how to get started with machine learning, how to install everything, and set up the default samples. In this video though, I want to show how to build your own agent that you can set up that's relatively simple. Again, I want to start this off with a really easy example so that everybody can kind of catch up, and it took me a while just to figure out this easy one. So hopefully this is a good stepping stone, and then we'll move on to even more advanced machine learning problems as we go forward. So what I've got here is just an agent, this number agent right here. It just picks a random target number between -1 and +1. And then the job of the agent is just to get to that number using two actions. There's a or a button to go up and a button to go down, and it just has to figure out the correct one. So I've also set up sphere and a cube here, and the sphere goes to the target. The cube is just the current value. So you can see it makes it to the sphere pretty much every time after I figured out how to get it to learn right. But it does kind of wobble around. It's not 100% perfect, but it's pretty damn good, I think. So I'm going to show you how to set this up. We'll go step by step, just build out the code, run through the process of training it, and then again, later on, I think we'll do some more advanced videos where we do more than just two actions and two pieces of state. So to get started, I've just created a folder here with a blank basic agent. So we have this number demo agent, and the base class is agent. And now in this, we need to override a couple of methods. So the first thing we'll do is override our, let's go for collect state. So we're going to override collect state. This is just going to return back a list of floats. Now there are two floats that we need. We have the target number and the current number, and that's all that we're going to give to the brain. So we're going to create a new list. So just do list of float and call this state equals new list of float, and then we do state.add, and we need the current number, and then we also need to add the target number. Now neither one of these exists yet, so we'll have to create these. But first, here, let's set up the return statement. Return state. Okay, so let's generate a current number and a target number. Just hit control period to generate a field, by the way. Well, control period and then enter. Just auto generates that. And we'll make these visible in the editor. Add the serialized field attribute just so we can see it and watch. We don't actually need it to be there, but it's nice to be able to see it. Now, how are we picking our target number? That's pretty simple too. We just override the initialize agent. Wait, was it initialize? No, agent reset. We override agent reset. So this happens after every completion. So whenever it fails or finishes, agent reset gets called. And our agent reset just needs to pick a random number. So we'll just do target number equals Unity engine.random.range, and we'll just go -1 to +1. We also want to reset our current number just to 0, and then we'll move spheres and cubes later. First, let's just get the numbers going. Now, the final method that we need to override is the agent step, and this is called, think of it almost like an update. So just do override agent step. And this one takes in a float array of actions. Now our actions are going to be pretty simple. We're going to have, an action of 0, which will be move down, so decrement our current number, and action 1 will be increment our current number. And in the editor, we can bind these to like left and right arrow keys, or keys 0 and 1, or 1 and 2, or whatever we want to test it ourselves in player mode. But just remember, we're doing two actions, 0 and 1 for down and up. So how do we set this up? Easy way to do it is just do a switch on the action. And let's cast it as an int even. So cast action 0. So again, this is an array of actions. We want the first one, 0, out of there. It's all that we care about. And when I say it's got two actions, there's two values that we could set it to, 0 and 1. So on case 0, we just want to decrement our current number. Let's do current number minus equals, and we'll just reduce it by 0.1, and then break. And then if we have the value of 1, just do current number plus equals 0.1f break, and then default will just we'll just return. If somehow we get a number that's outside this range, we probably want to throw an exception or something, but I'm just going to return here. We don't care. Now, how do we score this thing? So what's going to happen is this agent step is going to get called every step, or essentially think of it again like an update. And what we need to do is tell the agent when it made a good choice or a bad choice. And we don't do this actually like per choice. We do it based off of the state and giving it a reward. So what I want to do first is just check to make sure that the number doesn't go too far out of bounds. So we know that the number is going to be between -1 and +1. So what I've done is just put in a check to see if the current number is less than -1.2 or greater than, current number is greater than +1.2. In that case, I want to give it a reward of -1. -1. So that's essentially a complete failure. And then we mark done as true and return. So if we failed, we want to tell it, hey, your reward is -1. You've totally failed. You're done. When it's done, essentially what's going to happen is the reset will get called and it'll kind of restart on the next iteration. And then we just bail out because we don't want to do any of the other code after this if we failed. Now, if we haven't failed, what we want to do is get that distance. So we want to get the difference between the current number and the target number and see if it's close enough. I don't need them to exactly match since we're doing a random check. We just want them within, some little point of variance. So, you know what? I just realized I want an extra decimal point here. 0.01, because that's what I'm going to use as my check to make sure that it's within 0.01 of the target number. So to do that, here, let's store the difference like this. So we'll do float difference equals mathf.absolute target number minus current number. So this will just give us the difference between these two numbers as a positive value. And then we want to do if difference is less than or equal to 0.01f, then we're going to count this as a success. So then we do reward equals 1, done equals true, and again we'll just return out. We've won. And that's really all we need. So we've got this in here. But if you saw my example, you see I actually had some text on there and I was writing out some numbers to debug things, showing some cubes, and I want to kind of put all that back in here too, just to make it really, really easy to tell what we're doing. So I'm going to add a text field. So just add another serialized field for private text. We got to add the using statement for unityengine.ui. And I'll just call this text. And then I also want to add in, I want to add in a count of the solved ones. So I'm just do like a int solved. And we're just going to increment that every time we successfully solve something. So just do like, where's my successes? Right here. Here I'll just do solved ++. And then up here, we'll do if text is not equal to null, then we do text.text equals string.format. And I want to put in the current number, the target number, and the solved count. So I'll do 0, and then a slash and 1, and then put in some square brackets, 2, like that. And that's going to be our solved count. So the first parameter will be the current number, second will be the target number, and the third will be solved. In fact, I'm going to put some markers here too. So C for current and T for target. And then that's our solved. Yeah, there we go. I think that's probably good enough. Now let's jump over to the editor and give it a play. So if we go in here, first let's set up the scene. We don't have a scene yet. So let's do that. First thing we need is an academy. So just create an empty game object and we'll call this number academy. And we need an Academy script. I'm going to use this box Academy script. It's literally just an empty class that inherits from Academy. We are not doing anything special on a step or on a reset of the Academy for this, since the example is relatively basic. We don't need to like respawn something or pick a random place for anything. Our number agent does all the little bit of work that we need there. And we also need a brain underneath that though. So I'm going to add another empty gamma object, and I'll call this number brain. And we'll just add a brain component. So again, if you need an Academy, just create like a blank script, derived from Academy, and you'll be good to go. Next, we need the agent. So again, we'll create another game object, and we'll call this number agent. And we're going to add this number demo agent script that we just created to it. In fact, I'm going to name this right, number demo agent. Now we need to assign the brain. And we need a text object that we can update. So I'm just going to go to game object and UI and text. Create a little text. I'll maximize this. I think we should give it a bigger font size, maybe like a 50. Center everything. And that should be good. So we've got a text object there. This new text will get replaced with our values. Now go back to the agent, assign that text. And I'm going to go to the brain now, and the brain is in player mode, which is what I want when I'm testing this out and building it up until I start training. So I want to leave that in player mode. I'm going to need to assign the actions here, but first I need to get the parameters right. So our state size is at not 1, it's actually 2. And again, you can look at that in the agent. So if we open up this agent, you see we're returning back 2 floats. So our state is 2. And our action size is also 2. We have 0 and 1, so 2 actions. So we're going to need to set that as well. So we've got, let's see, go back onto the brain. Action size is 2, state size is 2. We can put in descriptions for these. We don't have to, but we can do like decrement and increment. Now our action space type is going to be discrete. So that just means that our actions are integers, they're not floats. So imagine if we had another set of actions that took a range from 0 to 1. Maybe it's like simulating controller input where you're not always at 1 or 0, you're somewhere in between. Or some other action that's a float. Then we would switch to continuous. Since we're on an int, we're going to go with discrete. And our state space, again, since we're actually returning back floats, just these numbers, we want to use continuous. If we were returning back integers, we'd switch over to discrete. Now I need to define the actions, so I'm just going to put in 2 here. And let's go with, let's see, left arrow maybe? Where's left arrow? Oh, it's way off the screen. Here, I'm going to go with something simple. Let's go with A and B. Now the value for A is going to be 0, so that'll be decrement. And the value for B will be 1, which will just be our increment. Now save this off. Let's put this in here. Let's call it demo. And we're saved. Now if I hit play, I should be able to go A and B up and down to get those numbers. Oh, let's see. Let's get the scale right. There we go. So here you can see once I get to the positive 0.8, we should get a success. So we got a positive success right there. Now we need to go up to 0.35. Just keep hitting it. Once I get in range, there we go. Got to it, and we scored again. And again, it looks like this is just going up again, just waiting for a negative. So now I actually have to know to go down with A until I get a negative 0.44 and another success. So that's working. We're getting the successes marked off, which is where we're doing that reward of 1, and up and down actions correctly modify our numbers. So how do we train this? Well, the first thing we need to do is switch over our brain type from player to external. Save my scene, and then we need to do a build. So just go File, Build Settings. We need to make sure that we add the current scene and make that the starting scene. There we go. Drag that right up here. You can see I've been playing with quite a few different options. Then we just do a build, and we'll name this thing Number Demo. And once that's done, we're going to open up our Jupyter notebook. There we go, almost there. Cool, so it finished the build. Now what I want to do is open up my Anaconda prompt. So just open up the Anaconda prompt here, and then I'm going to browse over to that folder where my project is and the Python subfolder next to it. As soon as it finishes loading up here, there we go. So do cd back to ml-agents, then go into the Python folder, and then we need to run it's Jupyter, Jupyter space notebook. And then this should open up a web browser for me in just a moment. Oh, there we go. So it's up right here. And I want to open up the ppo.ipynb file. Now, the first thing I need to do is make sure the environment name is correct. We named this one, was it number demo? So I need to make that match. Number demo. The other thing that I did was play with these settings. So the hyperparameters here. There's a good document that gives a little bit of guidance on where you want these values to be based off of the size of your state and the type of your state. I still don't completely understand all of them or know exactly how it all works, but I went with a little bit of the guidance there, dropped some of these numbers since my state is pretty small, and it seemed to work pretty well. So these are the numbers that I went with, and again, we'll see how it goes in this set of training. So what I want to do now is just click on this first little cell, hit the run cell, wait for it. The little star just means it's running. It takes a second the first time you start this thing up. So it should go any second now. And then we'll kick off the next one as soon as it's done. One thing to note too, if it ever just isn't working for you, you can't get it to launch, what I usually do is just hit the restart the kernel with the dialog thing right here, this button, and it seems to kind of reset and fix everything up. Okay, so that one's done. Now just run number 2. There we go. The numbers are not super useful because they're already set and they're just getting overridden. But usually it's like the number, the order that they were executed in. Okay, so number 2 is done. That one's always fast. Then load the environment. And then the first time you do it, it's going to ask for access like this if you're in Windows 10. And then you'll get a little pop-up of the window. Should come up sometime soon. There it is. So there's the little window. Just wait for that. Now, one thing I've noticed is sometimes it does bug out too, and you'll see some red text in here, connection errors and stuff. Again, just kill the little window, restart the kernel, and then try again. It happens, especially if I try to train multiple times in a row, it seems to be pretty likely to break. In fact, I think it may have broken here. It's normally really quick to start, so we're just going to kill that, restart the kernel, and try one more time. So let's give this another shot. Again, takes a second to start up after the first time. It's like up to a good 30 seconds or so. Okay, that one's done. Next step done. Load the environment. Hopefully it just works this time. Just give it a moment. It says successfully started. And then we're going to train agents. So now that I've hit that, we just need to wait. So you should see the Unity window up and running. Here you can see it's doing things. But we're not going to see any feedback for maybe 30 seconds or so. And eventually we'll start seeing some logs here. Mean reward 1.0. It seems really high. It's much higher than I expected on the first run. Well, let's see. Let's let it keep going. Generally, what I've seen here is that the reward starts off low, like around a 0 or slight negative, and then goes up. We don't want it going the opposite way, which it looks like it might be doing now. I don't know. Let's see. Again, this is a pretty simple example, though, so maybe it's okay that it got straight to 1. 1.0. Just keep letting it go. We need to keep going until this thing saves. So it'll be 2 more updates here. Less promising and exciting than I expected. Like I said, usually in all the other ones that I've done testing, it's, starts off low, gets up to around a 1.0, sometimes higher based off of how I have things set up. Okay, there we go, though. That's done. So I'm going to stop this section. Just selected that section and hit stop. Then go down to the export section and hit run. Run that step. And what it's done is output a bytes file. So if I go into the output folder here, which is the Python/model/PPO, you can see all of the exported previous ones that I've done. But the one we care about here is numberdemo.bytes. So I'm going to drop that file into our project. So here, I'll just drop it into this numberdemo folder. And I need to kill this little Unity instance that's running of our app. And then we will go to the brain. So go to number brain, switch it from external to internal, assign numberdemo as the graph model. Hit play, and if everything worked, it should just start training and getting positive numbers. So it looks like it's working. It's getting success multiple times. Now the last thing I want to show before ending this off is the visualization part. So since at the beginning I had a cube and a sphere, I just want to create those and put that in here so you can see it. So here I just want game object, create a cube, game object, and create a sphere. And then in my agent, numberdemo agent, just add 2 fields for transforms. So again, just in the serialized field, I have a transform of cube, and then I'll copy that and we'll do the sphere one. Then in the agent step, so where was it, I guess? Right here, just do cube.position equals new vector 3, and just the current number times 5, and then 0 and a 0. And the only reason I did times 5 is just so that we see some real movement. Otherwise, we're just moving like 1 meter each way. This way, you see, like I said, the number isn't the actual position, and we're just using that to visualize this thing. So this makes the visualization a little bigger. And the other thing we need to do is in the agent reset, we just do sphere.position equals new vector 3, target number times 5, comma 0, comma 0. Let's see, if I didn't make any typos there, we should see our cube and sphere appear, and then just the cube moves towards the sphere. Let's watch one more time. Oh, if I assign things. So I've got the agent, I've got the 2 fields here. We need to assign the cube, assign the sphere. We'll do a quick save, hit play one more time, and we should be good to go. There you go. You can see the cube getting closer to the sphere, and it is kind of wobbly. I think if we do more training on it, the training file that you saw at first, I had to let it run through many iterations, basically until it quit, which took about 10, maybe 20 minutes at most. And it seems like it got quite a bit better here. It's not quite as smart. It's a little wiggly. It eventually gets there, though, and it's never going the wrong direction and totally failing. So it's a good first step. Like I said, it's pretty basic, pretty simple. We're just trying to find the correct number and the right path to that number. Of course, you could just do this in your own logic super easily, but we're trying to figure out the machine learning part and then build into something much more advanced that's figuring out really complex problems. But I think this is a nice, easy way to visualize how you set the things up, how you code in rewards, and make the system kind of work. One thing that I have noticed too is that using positive rewards for good behavior seems to work better than negative rewards. So just positively rewarding anything that you want the agent to do seems to train better. That could just be, a fluke of my experience, but it's what I've seen so far. So I figured I would share that. Anyway, again, I'll do some more videos on this stuff soon with some more complex examples. I want to do some things like cannons, shooting at things and hitting the right target, all kinds of fun stuff. So if you're interested in that kind of stuff, don't forget to subscribe, hit the little notification thing, and of course, don't forget to like the video. Again, thanks for watching.